All right, so welcome to this deep dive. You gave us like a ton of research papers on how we humans like decide how confident we are about things.
It's a fascinating area.
And yeah, we're going to take a deep dive into that.
Yeah, buckle up. We're going into the world of computational models.
Yeah, so these aren't just like any models, right? We're diving into like the research of Medha, Shekhar and Dobromir Rahnev.
That's right.
From Georgia Tech School of Psychology.
Yeah, they've done some really cool work on how we understand this like process that feels so simple.
Yeah.
But is actually really complex.
Yeah, you think like confidence, like, yeah, I'm confident or I'm not confident.
Right, exactly.
But like, how does that actually work in the brain?
Yeah, and they've been really trying to push the boundaries of our understanding of it.
Yeah, so you've basically saved yourself hours of reading these like really dense papers because we're going to break it all down.
Absolutely.
And like the main course for today is a paper titled, How Do Humans Give Confidence? A Comprehensive Comparison of Process Models of Perceptual Metacognition.
Yeah, that's a mouthful.
Yeah.
But it's a really cool paper.
But before we like get to the main event, how do they even know that like all these models that they're comparing are like different enough to even be worth comparing?
Yeah, that's a great question.
Like what if they're all the same model?
Right. It'd be like, going to a baking competition and all the cakes taste exactly the same.
Right.
What's the point? Right. So they first had to make sure that each model produced a distinct, like flavor of confidence judgment.
Yeah.
And they did this by using something called model recovery analysis.
Model recovery analysis.
Yeah.
Okay.
Yeah.
That sounds kind of intense.
It's a cool technique. So imagine, like each model is a suspect in a lineup.
Okay.
And the researchers, they're like the detectives.
They've got the magnifying glass.
Yeah, they want to see if their statistical tools can accurately pick out the guilty model, the one that actually best reflects, how our brains work.
So they're looking at all these models and they're trying to see if they can like pick out the right one.
Exactly. Yeah, and this is a crucial step because it makes sure that when they do compare them later on, they're actually comparing apples to apples,
right,
and that the insights they get are reliable.
That makes sense.
Yeah.
So, okay, they confirm that like these models that they're comparing are distinct?
Yeah.
Did they just like throw them in the ring and see which one wins?
No, not quite.
Okay.
They took 3 large data sets.
Okay.
And we're talking thousands of trials here where people had to do things like, figure out which way dots were moving on a screen, or identify, the orientation of a shape, and then they would rate their confidence in their answer.
Okay. So pretty straightforward for the participants.
Yeah, pretty straightforward for the participants. But the cool part comes in the analysis, where they took each of these models and they're like, okay, you model.
Yeah.
What do you predict people's confidence ratings would be?
Right.
And then they compare that to the actual human data.
Okay.
To see which one does the best job.
Okay, so who won? Like, is there one model to rule them all?
That's where it gets interesting. There wasn't a single winner.
Oh, dang it.
Turns out different models were better at explaining different aspects of confidence.
So it's like our brains don't just use one way to figure out how confident to be.
Right.
It's like we have different tools.
It's a toolbox, yeah.
Okay.
And, they pull out the right tool for the right situation.
So like for simpler tasks, like in their first experiment, one model that did really well was called the log-an model.
Yeah, the log-an model.
Log-an model.
Okay, that's a good one.
That sounds technical.
Yeah, so log-an stands for log-normal metacognitive noise model.
Okay.
And it's basically saying that our confidence is affected by the specific kind of noise in our brain.
Okay.
And get this, the stronger the information we base our decision on, the stronger this noise can actually get.
Okay, so if I'm like looking at a really clear picture,
yeah,
my confidence might be like more easily swayed by this noise than if I'm looking at something that's blurry.
Exactly.
That's kind of counterintuitive.
It is a little bit, yeah. It's like, imagine you're trying to hear someone whisper in a quiet room versus in a loud concert.
Yeah.
The whisper's going to get lost really easily, but the concert, you're going to be able to hear it.
Right, even with some background noise.
Even with the background noise, exactly.
Okay.
So in the same way, the log-an model is saying that our confidence in those clear-cut situations might be more susceptible to this random neural noise.
So the log-an model does well with like simpler tasks.
Yeah.
What about when things get more complex?
Well, in their second experiment, they actually made things a little bit harder.
Yeah.
They had 3 levels of difficulty. And the log-an model still did pretty well. But another model emerged as a strong contender.
Okay.
This one was called the WEV model, or the Weighted Evidence and Visibility model.
Okay, before we go any further, can you unpack that one for me?
Okay, so Imagine you're trying to identify a fruit in a bowl.
All right.
If you can clearly see the fruit, you're probably going to be more confident about what it is.
Right. Yeah.
The WEV model basically says we use this visibility, how easy it is to process the information as a shortcut to estimate our confidence.
So it's not just about like the evidence itself, but like how easy it is to like see that evidence.
Right, exactly.
So like if I have to squint to see the fruit, I might be less confident.
Exactly. Even if you think you know what fruit it is, if you have to work harder to see it, you're going to be less confident.
So it's like a rule of thumb?
Yeah, it's like a rule of thumb our brains are using. If it's easy to process it, we tend to feel more confident.
Got it.
But this is just, one piece of the puzzle. There's more to uncover as we delve deeper into their experiments and the models they tested.
Okay, let's do it.
All right. Now, their third experiment, they really upped the ante.
Okay.
They had 8 levels of difficulty.
8 levels.
8 levels, yeah.
Okay.
And a new champion emerged.
Ooh.
The PE model.
PE model?
Yeah, or the positive evidence model.
Okay, so what does this PE model do? Like, is it like super powerful?
Well, it basically highlights a very human tendency.
Okay.
It suggests that when we're like trying to figure out how confident we are, we tend to focus on the evidence that supports, the answer we chose.
Okay.
And we kind of downplay the evidence that might contradict it.
So it's like confirmation bias.
Yeah, exactly. It's like confirmation bias, but for confidence.
So we're like clinging to the stuff that makes us feel good?
We like to feel certain.
Yeah.
We ignore the stuff that might make us doubt ourselves.
Right. And this is probably even worse when the task is like really hard.
Yeah, especially when we're already feeling a bit uncertain.
Okay, so we've got the Lodgin model for simpler tasks.
Right.
The WEV model for when it's easy to like see the information.
Yeah, when that visibility is important.
And the PE model when things get tough.
Yeah, when we start grasping at straws a little bit.
Are there any other like interesting models in this confidence tournament?
There are. Some models actually suggest that our brains might be using 2 completely different systems for making decisions and judging our confidence.
Whoa. So it's like having 2 brains.
Kind of, yeah. It's like a split personality, but for certainty.
Okay, tell me more about these like dual system models.
So one example is the dual channel model,
or
the DC model for short.
Okay.
And this model says that decisions where we have high confidence, those are handled by a conscious pathway in our brain.
Okay.
And then the low confidence decisions, those rely on a more unconscious pathway.
So if I'm like super sure about something, it's like my conscious mind is in control.
Yeah.
But if I'm like, I don't know. It's like my unconscious mind is taking over.
That's the idea.
Yep.
Yeah, but Shekhar and Rahnev's research actually suggests that this might not be the case.
Oh, okay.
The DC model didn't really match up with the human data.
So another model bites the dust. Okay, so what other models are left?
Well, there are a couple more that bring up a really interesting idea.
Okay.
What if the evidence we use to make a decision and the evidence we use to judge how confident we are, what if those are pulled from different sources?
But even if they're like related to the same thing?
Even if they're related, it's like looking at 2 different maps of the same city.
Okay.
They show the same landmarks, but the details like the streets, the routes, might be slightly different.
Okay, I can see that.
So the SDRM, or the stochastic detection and retrieval model, and the SOC model, or the second order confidence model, they both kind of explore this concept. They suggest that our brains might have these different internal compartments. And they're pulling information from those different compartments when they're like, okay, how confident are we?
So our confidence isn't just like a mirror of like what we're thinking when we make the decision.
Right. It's not just a direct reflection.
It's like more complicated than that.
It's more nuanced. Yeah.
Okay. And that could explain why sometimes we're like super confident, but we're wrong.
Exactly. Yeah. If the information we're using to judge how certain we are is like slightly off from the information we use to actually make the decision, then it makes sense that there would be these like biases and inconsistencies.
Makes you wonder if we could like train our brains to get better at this.
Yeah, that's a good question.
Like, is there a way to align those maps?
Yeah, that's a fascinating area of research.
But I'm not going to lie, it's a little hard to keep track of all these models.
I know there's a lot.
Is there like a way to simplify all this? Like, what's the main takeaway?
Yeah, so what really stood out to Shekhar and Rahnev was that 2 models consistently performed well across all the different experiments. And they captured a lot of like the patterns in the data.
Who are these like all-star models?
The LogGN model, which we talked about earlier, and the WEV model.
So what happens when you put these two all-stars on the same team?
Well, that's exactly what they did.
Okay.
It created a hybrid model combining elements of both the log-EN and the WEV model.
A hybrid model. That's cool.
Yeah.
What do they call it?
They called it the log-WEV model.
Okay, log-WEV.
Yeah.
So they took the best parts of both.
Yeah, they took the best of both worlds.
Okay, so what makes this Frankensteinian creation so special?
Well, it incorporates both the idea of signal-dependent metacognitive noise, which we talked about with the log-EN model.
Right, like the clearer the signal, the more noise there is.
Exactly. And the concept of this visibility bias from the WEV model.
So how easy it is to process the information affects our confidence.
Exactly.
Yeah.
So it basically acknowledges that our brains have these tendencies that can mess with our confidence, whether it's the noise or the shortcuts we take, based on how easy it is to see the information.
Right.
And when they tested this hybrid model, it performed really well, even better than many of the individual models.
Wow.
So it seems like they might be onto something here.
That's really cool.
Yeah.
This is all super fascinating. It's like we're getting a glimpse inside our own minds.
Yeah.
But I think before we get too lost in all these models, I want to hear from you, as the expert of all these models and all these insights, what should we as regular people, what should we keep in mind about confidence, in our daily lives?
Well, I think the biggest takeaway, especially with this log-WV model, is that confidence is a feeling.
Okay.
It's subjective. It's not always a perfect reflection of reality.
So just because someone sounds really sure about something, it doesn't mean they're right.
Exactly.
And if someone's I don't know, it doesn't mean they're wrong.
Right. We got to be careful not to just assume that confidence equals competence.
Right.
As Shekhar and Rahnev showed, our confidence can be influenced by so many things.
Yeah.
Like the strength of the evidence, how easy it is to understand the information, and even just our own biases.
It's we have all these little quirks in our brains that mess with our confidence.
Exactly.
But is there any way to get better at this?
That's a good question.
Are we stuck with these biases, or can we learn to be more aware of them?
Well, that's the encouraging part.
Okay.
We can actually get better at calibrating our confidence.
Really?
Yeah. It's fine-tuning an instrument.
Okay, so is there a secret formula? How do we become confidence gurus?
No magic formula, unfortunately.
Okay.
But studies have shown that getting feedback on our performance, especially on how we judge our confidence, can help us become more accurate.
So it's like having a coach.
Yeah.
Who can tell us when we're being overconfident or underconfident.
Exactly.
And that helps us adjust.
Yeah, and the feedback doesn't even have to be that complicated.
Okay.
Even just knowing if our confidence rating was too high or too low can make a difference over time.
That's good to know.
Yeah.
So we can train our brains to be more confident.
In a way, yeah, we can train our brains to be more aware of our confidence.
And more accurate with it.
Exactly.
Are there other ways to do this? Are there mental exercises or something?
Yeah, that's a really interesting area of research.
Okay.
Some studies have shown that mindfulness practices, which focus on being present and aware of our thoughts and feelings, might actually help with confidence calibration.
So if we're more in tune with what's going on in our minds, we can make better decisions about our confidence.
Exactly. Instead of just blindly trusting our gut.
Yeah.
We take a step back, observe what's happening, and then decide, okay, how confident do I actually feel?
That makes a lot of sense.
Yeah.
But confidence isn't just about being right or wrong.
Right.
It's also about our motivation,
Absolutely.
how much we're willing to keep trying.
Yeah.
And even just our overall well-being.
Yeah. Exactly. It's not about being perfect or being some kind of robot.
Right.
It's about finding that balance, being confident enough to take risks and go after what we want, but also being realistic about our limits and knowing that we might make mistakes.
That's a great point.
Yeah.
This has been an amazing deep dive.
Yeah, it has.
We've gone through all these amazing models from Shekhar and Rahnev.
Yeah.
We've learned about these hidden biases that mess with our confidence.
Right.
And we've even figured out some ways to get better at it.
Exactly.
Yeah, and I think the biggest thing I've learned is that even though confidence can be a little bit quirky,
yeah, it definitely has its quirks.
It's a really important part of what makes us human.
It really is.
So thank you so much for joining us on this journey into the world of confidence.
It's been a pleasure.
We hope you've learned a lot and that you'll come away with a new appreciation for how complex and fascinating confidence really is.
Absolutely.
So until next time, happy deep diving.